Hello everyone. Today we will understand an important topic in analog electronics, amplifier driver board. In any audio amplifier system, the driver stage plays a very critical role. It works between the preamplifier stage and the power output stage. Without a proper driver stage, the output transistors cannot receive enough signal strength to drive the speaker efficiently. So in this video we will learn what is an amplifier driver board, block diagram of amplifier system, basic components required, circuit design of class up driver stage, working principle, PCB design guidelines, power supply design, testing procedure, common problems, applications. Let's begin. Introduction to amplifier driver board. A driver board is an intermediate electronic circuit used in audio amplifiers. It is placed between the preamplifier stage and the power output stage. The main functions of a driver board are voltage amplification, increasing the input signal voltage, current drive capability, providing enough current to drive power transistors, bias stabilization, maintaining proper operating conditions. Driver boards are commonly used in audio power amplifiers, especially in Class AB and Class B amplifier designs. These amplifier types are widely used in home audio systems, professional sound systems, and musical amplifiers. Block diagram of amplifier system. Now let's understand the block diagram of an amplifier system. The amplifier consists of 5 main blocks. First is the input signal. This signal may come from a microphone, mobile phone, music player, or audio mixer. Second is the preamplifier. This stage amplifies very weak signals to a usable level. Third is the driver stage. This is the most important stage that increases the signal strength and prepares it for the final power stage. Fourth is the power output stage. This stage uses power transistors to deliver high current and power. Finally, the amplified signal is sent to the speaker load, which converts the electrical signal into sound. The driver stage ensures that the power transistors receive a strong and stable signal. Basic components required. To design an amplifier driver board, we need several electronic components. First are the active components. These include transistors, such as BJT or MOSFET. A driver transistor pair, typically an NPN and PNP transistor. These components perform the amplification process. Next are the passive components. These include resistors for biasing and feedback control, capacitors for coupling and bypassing signals, diodes used for thermal compensation. In addition to these, we also need supporting components like heat sinks to dissipate heat, PCB board to mount the components, power supplies such as plus or minus 12V, plus or minus 24V, or plus or minus 35V depending on amplifier power. These components together form the driver circuit. Circuit design, typical Class AB driver stage. Most audio amplifiers use a Class AB driver stage because it provides good efficiency and low distortion. A typical driver circuit consists of 4 main sections. First is the differential amplifier. This stage acts as the input stage and compares the input signal with the feedback signal. Second is the voltage amplification stage, commonly called the VAS. This stage provides large voltage gain. Third is the driver transistor stage. This stage increases current capability so that the power transistors can be driven properly. Fourth is the biasing network. This network may use diodes or AVB multiplier to maintain proper bias voltage. This design ensures low distortion, thermal stability, smooth signal amplification. Working principle. Now let's understand how the driver board works. When a small input signal enters the circuit, it first goes to the differential amplifier. The differential amplifier processes the signal and sends it to the voltage amplification stage. In the VAS stage, the signal voltage is significantly increased. Next, the signal moves to the driver transistor stage. Here, the driver transistors increase the current capability of the signal. Finally, the signal drives the power output transistors, which supply large current to the speaker. Because of this process, the driver board improves signal linearity, circuit stability, output efficiency. PCB design steps. After designing the circuit, the next step is PCB design. The circuit can be designed using software tools such as Proteus, KeyCAD, EasyEDA. During PCB layout, some important guidelines should be followed. First, place components logically. Keep the signal section away from the power section to reduce noise. Second, use thick ground tracks for better current flow. Third, keep feedback paths short to maintain signal stability. Finally, provide enough space for heat sinks, especially for driver and power transistors. A good PCB layout improves amplifier performance significantly. Power supply design. An amplifier driver board requires a stable power supply. Usually, a center-tapped transformer is used. The transformer output is converted into DC using a bridge rectifier. After rectification, filter capacitors are used to smooth the DC voltage. Typical capacitor values range from 2200 microfarads to 4700 microfarads. In some designs, voltage regulation circuits may also be used. Examples of power supply configurations include 12-0-12 volts for small amplifiers, 24-0-24 volts for 100 watt amplifiers. A clean power supply helps reduce noise and distortion. Testing procedure. Before using the amplifier, proper testing must be done. First, inspect the PCB carefully for any short circuits. Second, power on the circuit without output transistors initially. This protects expensive power devices during testing. Next, measure the bias voltage to ensure correct operating conditions. After that, check the DC offset at the output. The output DC voltage should be very small, ideally close to zero. Once everything is confirmed, the speaker can be connected safely. Common problems. Sometimes amplifier driver boards face common issues. For example, overheating may occur due to improper bias settings. Distortion can happen if the feedback resistor values are incorrect. Noise problems usually occur due to poor grounding or PCB layout. And if there is no output, the reason might be a faulty driver transistor. Proper circuit design and testing can help avoid these problems. Applications. Amplifier driver boards are widely used in many audio systems. Some common applications include home audio amplifiers, public address systems, guitar amplifiers, subwoofer amplifiers, DIY audio electronics projects. Because of their ability to drive power transistors efficiently, driver boards are essential in modern audio amplifier design. Conclusion. So today we learned about the amplifier driver board, its circuit design, working principle, PCB design, power supply, testing, and applications. Understanding the driver stage is very important for anyone working in analog electronics, audio engineering, or amplifier design. Thank you for watching.